Design procedure for curved beams. So first we'll look out for symbols used in curved beams. So this is a curved beam and these are the symbols used for a curved beam. So every curved beam has a center. This center is called as center of curvature. So this radius is called as the inner radius, Ri. So this can be represented on a section view. So this is the inner radius Ri. Then this is the outer radius Ro. So this can be represented on a section. So this is the Ro, distance from the center of curvature to outermost fiber. Then a curved beam has two axes. Those are centroidal axis and neutral axis. So centroidal axis, the radius of centroidal axis is called as RC. This is the RC. So on this is the RC. The radius of neutral axis is called as RN. So from the center to the central neutral axis is called as RN. This is RN. Then the distance from inner fiber to neutral axis is CI. Distance from outer fiber to neutral axis is CO. And distance from inner fiber to central axis is C1. Distance from outer fiber to central axis is C2. Now the procedure. So first we need to find the inner radius Ri, which will be given. Then based on the dimension, find Ro. Then centroidal axis RC. Then neutral axis Rn. So we have formula for these two. Then eccentricity is the difference between RC and Rn. So here in the figure, so RC minus Rn is E, eccentricity. So E equals to RC minus Rn. So Ci, so from the figure, so Ci is Rn minus Ri. So Ci is Rn minus Ri. Co, so in the figure Co is Ro minus Rn. So Co is Ro minus Rn. C1, so C1 is the distance between RC minus Ri, we get C1 distance. So C2 is Ro minus RC, we get C2. So force will be given. So L is the distance between the force to centroidal axis. For example, so here for this figure, suppose this is the force and this is the centroidal axis. The distance from the force to centroidal axis is total length L. Then A is area of cross section. So this area is area of cross section. Then bending moment MB is F into L. So multiplying F into L, we get bending moment. So next comes bending stress at inner fiber, sigma BI. So MB, CI, AE, RI. Substituting, we get MB, I. Similarly, so depending on the force, is tensile or compressive. If this is the condition, so this inner side is tensile, outer side is compressive. Bending stress at outer fiber, MB, CO, AE, RO. So depending on the load, is tensile or compressive. So here, so if the load is compressive, so inner is compressive, outer layer is tensile. So direct stress is F by A. This also is tensile or compressive, depends on the load. So 17 combined stress at inner side is sigma Ri is sigma D plus sigma Bi. So it may be tensile or compressive. So for example, if sigma D is 5.2 tensile and sigma Bi is 3.4 tensile, then it both can be directly added. So we get the answer as T, positive, that's tensile. So combined stress at outer side. So sigma D plus sigma BO, we get sigma RO. So it may be tensile or compressive. So for example, if sigma D is 5.2 tensile and sigma BO is 26.2 compressive, then we have to minus 1 sigma BO. This plus and this minus, so we get minus 21. So it minus, I just said, it's compressive. This was the procedure for the chord beams. Now how to calculate RC and RN? Now to calculate RC and RN for symmetric sections like circle or rectangle, RC is half. RC is half the section plus Ri, we get RC. So half the section plus Ri, we get RC. But for unsymmetric sections like trapezium, we have to find RC. Now to find RC, we have formula C1 equals to H by 3, Bi plus 2 BO, Bi plus BO. So Bi is the inner side of the trapezium, BO is the outer side of trapezium, H is the thickness of the or depth of trapezium. Now how to find, so substituting this equation we get C1. C1 is distance between the inner side to the centroidal axis, but therefore RC will be Ri plus C1, we get RC. So RC is Ri plus C1. Now how to find Rn for trapezium section? Rn is half H Bi plus BO, Bi BO. This we get in the data handbook. So equation number 25.62. So simplify this at once, this at once, ln of Ri by Rho at once, and this minus Bi plus minus BO at once. So multiply these two with minus with this and divide with this, we get Rn. Now for I section, how to calculate RC for R section? So this is I section. So to find RC, so we have a centroid x dash equals to a1 x1 plus a2 x2 plus a3 x3 upon a1 plus a2 plus a3. So a1 is the area of this is section 1, section 2 and section 3. a1 is area of this section, length into breadth. Area is this, a2 is this section area, a3 is this section area. And x1 x2 are the center of this section from here to the base. This is the base. So from here to here is called as x1, and from here center of this section 2 from here to here distance is called x2. The center of this section 3 distance from here to here is called x3. So substituting this, we get in this equation we get x bar. So x bar is the distance from, so this is we get, so this is the centroidal axis. So x bar is the distance from the central axis to the base is x bar, is x bar. So this distance is x bar, central axis to the base. So therefore RC will be Ri plus x bar, we get RC. So this is RC, so this is Ri, so Ri plus x bar we get RC. So Ri plus x bar we get RC. Now to find the Rn for I section. For that, first calculate the total area A1 plus A2 plus A3. Then we have this formula in detail book as question 25.63. So this is the equation. Substitute all these terms, simplify and add this, divide by the area, we get Rn.